Okay, so for 8-8, we get to talk about other non-rigid transformations. We call these ones other ones. They're not on the reference sheet. You're like, oh, we're done with transformations. We did reflections, rotations, translations, and finally in 8-7, we did dilations. But there are other ones, okay? They're called compressions and stretches. And they get very specific and detailed, but executing them is actually extremely easy, which I'll get to here in a moment. The first thing we have to understand is a compression decreases the distance between points. It squishes it, makes it smaller. It's kind of what you can think of a reduction from 8-7. That is when A is less than 1 but greater than 0. It's in between 0 and 1. Now a stretch means it's increasing the distance between the points. It's getting bigger, or an enlargement. Now both of these change the shape of a figure, which means this does not change, or this is not rigid. This is not a rigid transformation. That's why it says non-rigid transformations. Remember, the only 3 rigid transformations we deal with are reflections, rotations, and translations. These ones and dilations are non-rigid, okay? Now let's keep some things in mind. Horizontal, we know, is left-right, it affects the x. And vertical, up-down, it affects the y, okay? Now, this is quite simple right here. This is the notation. There's no function notation more specific than, hey, we're going to take xy, multiply a times x, b times y. And that'll be exactly how it's written. Like, you don't have to confuse this with the translation rule or anything. It'll be clearly written out like this. Now let's talk about the difference between them. If we are multiplying x by a number larger than 1, we call that a horizontal stretch. If we're multiplying x by less than 1, it's a horizontal compression. It's getting bigger smaller left, right. This one gets bigger left, right. This one gets smaller left, right. But if we multiply y by a number bigger than 1, it gets bigger up, down. Bigger up, down. Now, if we multiply it by a number less than 1, it gets smaller up, down. So let me show you guys some example problems to help you get a picture of this. So this is what I was just explaining about horizontal stretch. Gets bigger left, right. Horizontal compression gets smaller left, right. Vertical stretch gets bigger up, down. Vertical compression gets smaller up, down. The words go with it, okay? So this is how the problem would look. This is what we're looking for. It says transform it, xy, we're going to multiply 3 times x and 2 times y. It's that easy. We just take all of our original points, E, F, G, and H. We multiply 3 times all the x's, 2 times all the y's. It's that simple. Now, it gets a little bit harder when we were not given the rule, but we're saying, hey, what is the rule that we did to this? So we're given our pre-image in black and our image in blue. Now, with this one, we get to see that our pre-image is pretty long, and then it gets squished vertically. So we know that this is going to be a vertical compression. Now, it's not changing left, right, so nothing's happening to x. It's just y is getting squished, which according to our notes, if it's a vertical compression, whatever number we multiply by y is in between 0 and 1. So we have to figure out what that number is. We can do that by saying, hey, our image is 2. This is just like how we found a scale factor in 8-7. Image over pre-image. Our pre-image length, this is 2. This is 1, 2, 3, 4, 5, 6, 7, 8. 2 out of 8, that equals 1/4. So that means we multiplied all of our y's by 1/4. Okay, so it goes more into detail with that. There are videos on Savas of that example problem if you would like more detail. Let's look at one more. Actually, I'm just going to generally talk about this. It says we want to dilate it with scale factor of 2. So we're going to multiply everything by 2. And then we're going to multiply just x by 2. So it's kind of a double down. It says dilation with 2 means Dilations mean we multiply every x and y by 2. But then it's asking us just to multiply x by 2 again. So we do that. We dilate, and then we just do a horizontal stretch. Same type of situation here. It's having the pre-image. It's wanting us to first, it gives us, this is one of the ones where we have to work backwards. So it gives us P double prime, Q double prime, R double prime. And we're wanting to work backwards. So we're going to undo that horizontal compression and stretch it back out. And then undo that dilation of scale factor 1/3. Okay. Same thing here. With these problems, this often gets missed on the test, which will be coming up next week, right here soon. When we have to dilate it first, this point is at 1, 2. So if I'm multiplying y by 3/2, I have to apply that to y first before moving it. So I don't start with my original blue point to move it over here. I have to multiply it and then move it, okay? But in general, we just have to take the numbers, multiply them, look at the coordinates, and go from there. And that is what 8-8, other non-rigid transformations, is all about.